Hi everyone, we're going to do a few examples regarding work and calculating work. So the first example is determining work, whether it's positive, negative, or zero. Remember, this all has to do with the direction of the force and the direction of the motion and what they are or how they're related to each other. So notice here, we see that the motion of the box is lifted upward. And we see that the force is applied up, right, by the hand. And so if your motion is up and your force is in the upward direction, then your work value is going to be positive. Remember, same direction is positive. It doesn't matter if it's down, up, left, right, but as long as they are both in the same direction, you will have positive work. The second example you can see is the baseball player is sliding into the second base. So let's pretend, right, that the base is here, right, which we see here. And so his motion is toward, I'm going to draw an arrow, right, toward the base. Then notice it talks about the friction force, right, is actually being applied away. So it's really, remember, friction is always the opposite of motion. So if the player is moving, let's pretend, to the right, the friction force is to the left, right? So this is actually opposite direction. And if it's the opposite direction, then it will be negative work. Okay, if motion and then the force or the direction of the force and the motion are opposite of each other, then it will be negative work. Then finally, the last situation is the waiter is walking to the right, right? So the waiter is going this direction. The applied force, look, it says upward. Okay, so I'm drawing my arrow up. Well, notice this, right, is perpendicular. Perpendicular. Perpendicular, right, which means at a 90-degree angle from each other, right? This is 90 degrees from each other. This is actually going to be zero work. Okay, you're actually not doing any work. You can imagine with groceries, right? If you lift the groceries up from the floor, that lifting motion is work. But if you are actually carrying the groceries into the house or from the car or wherever it is, you're actually not doing work on that, on those bags, because you're lifting, or your force, right, is lifting or keeping it up, but your motion is going forward or, right, perpendicular. And so you're actually not doing work when it's perpendicular. Okay? Second example, calculating work. How much work does the person do on the block? Well, notice the person's force is 250 newtons. So I'm just going to highlight that. 250 newtons is force, right? And notice that the direction, right, is in the same direction that the force is, right? The person is pushing to the right and the block is moving to the right. So we can then say that the work is equal to the force, remember, times the displacement. Here's the displacement here. Let me highlight it, right? The displacement is 4 meters. So then, hold on, sorry. I'm going to erase this and let's make sure that we use our kind of our color coding. Remember, I'm going to do work is equal to, let me just make sure that I did work. Yep, okay. The force is blue times, right, displacement, which is pink. So then my force is 250 newtons I'm going to say that that is positive work. So I am going to put a positive in there, right? That this is positive 250 newtons, multiplied by my displacement, which is 4 meters. When I multiply those two together, my work ends up being 1,000 joules. Okay? How much work does the block do on the person? Remember, this is putting into play Newton's third law. Right? And Newton's third law says, right, equal and opposite force when objects are interacting. And so if our work up here is a positive 1,000 joules, we know that the block is actually going to do a negative 1,000 joules on the person because it's in the opposite direction. Right? The person is pushing the block to the right, and the block is exerting a force on the person to the left, right? Left is opposite of the motion of that block.